The topic, interplay of AI and emerging tech. AI in cyber-physical systems, technical innovations and social implications. We have with us this afternoon Shailaja Thakur, research scientist, IBM Research. Shailaja is a research scientist at IBM Research, and her primary research focus is on applying AI to develop efficient, reliable, and transparent systems. Her current work focuses on developing foundational models for code generation, reasoning, and alignment. And alongside, she also works on AI for social impact. Please put your hands together and welcome Shailaja Thakur.
This is for going forward, backward.
Back. Yeah, go back.
Thank you so much. And hello, everyone, and a very good afternoon. I know you have had a very long day, but I hope you have had a great day so far. So my name is Shalja, and I'm currently at IBM Research, Bangalore. Now, let me start with a fun fact about me. So you must be thinking, what do these scientists do when they are free or when they're not in the labs? So basically, when I'm not in the lab, I put my creative hat on, and I do some sketching and painting, which is what I'm showing off here a little bit. Okay. But today, I'm not here to talk about art. There is something that fascinates me as much as art do, and that is a world where intelligence transcends the digital realm and seamlessly integrates into the physical reality, right? So this is the world of cyber-physical system where it integrates with the AI. So I have used a little bit of heavy terms. I hope I'll be able to simplify those while we go ahead in the presentation. But let me start by asking you a few questions, right? So imagine a world, right, where the streets are bustling with the autonomous cars. They have unparalleled precision. Or for that matter, a robot in the digital healthcare, right? They're assisting their skilled surgeons at doing intricate procedures. Do you think you would be confident driven by an autonomous car? Like just a handful of the raises. Like, I know the opinions are going to be mixed because we have not reached there yet, right? So I know this question comes to my head as well because we don't have it in our day-to-day regular lives. But this is not a hypothetical scenario. This is a reality. And a glimpse of what the AI and the CPS is rapidly shaping up is something that we are literally living in terms of Delhi Metro, where you would see a handful of these trains being driven by the driverless. They're literally driverless. And they are being taken by hundreds and thousands of commuters on a regular basis every day. And I'm pretty sure if we go ahead and ask them the same question, their opinions may be also mixed, that maybe I do not want to take the train again if I know that it is driverless. So, okay, so this is just, yeah, so let's now try and understand what exactly is cyber-physical systems, right? If we understand it a little more, we understand what is really happening in the space of AI if we are talking about these systems. So imagine a world where you have the physical entities, right? The mechanical systems that we have, the cars, the trains, and the digital world, and consider these two converging together, right? Making a unit. Now, in that unit, consider the sensors as the ears and the eyes, right? So they collect the data. They collect all the data from the environment, and you have the actuators, which you can consider as the hands and the feet, who responds to these data, right? So by taking actions in the physical world. And at the core of all of this is what we call the controller. And what does the controller do? It is actually the brain of all of this, meaning it would actually do the decision making on the constant flow of information that is happening through these sensors and through these networks, right? So this is the dance between these physical and the digital world is literally the essence of what is happening in the CPS, right? Now, let's add AI to the mix, right? So if AI comes to your head, what is the first thing that comes or you think of? Data, right? There is lots and lots of data in some form or the other. It can be time series, it can be images, it can be text, you name it. And the second thing is we have algorithms, right? Which is learning patterns, making insights out of these data. And in the end, it would make some sort of action making or some decision making based on all of this that happened, right? So that's what is basically happening when we think of AI. So this learn from data component, when we add this to this CPS entity that we have, the role it has is that now our CPS is not only reacting, it is learning, adapting, and evolving over time. Why? Because we are feeding it the data that may be changing constantly over time. So our system is not like literally not just reacting. It is understanding and then reacting. So for instance, take the example of the cars, right? I'm sure you must have heard of driverless cars coming from Tesla and many other manufacturers. And they have been through generations, right? We have had mechanical cars with no sensors at all, to connected cars, which have like basic set of sensors, right? Which helps in automatically switching the windshield on or off, and so on and so forth. But those cars which are literally just connected, they still require humans for every action, for every turn, for every acceleration that they need to do. But now consider this car being equipped with AI. So this is an autonomous car that is equipped with AI, meaning now this will have much more sophisticated sensors, as you would see here, through which we are collecting a torrent of data sets, like literally huge amounts of data sets. And based on those data sets, now those are fueled into the algorithms that are sitting within these vehicles. And through this constant learning process that will be happening when we are fueling this data to the algorithm that is sitting in the car, that is making the car not only navigate through the environment, but also make sure that it helps in identifying hazardous situations, or for that matter, optimize its own performance over time, as well as provide much better driving personalized experiences. For example, let me take the example of how your mood may vary when you're driving, right? So sometimes you may be in a stress because of something, or maybe you're having a panicking situation, right? So your gestures, your moving expressions may be understood by the algorithm that is sitting there, and it may take an impromptu action, that is, let me call the medical services on your behalf, because you're not able to take that action for yourself. Or it could be something else, right? So these are all the various advantages that you can think of. I know there are disadvantages, and we may talk about it in some time, but these are all the various good things that are happening. And this is not happening in just this space. It is happening in various other spaces, you name it, such as healthcare, transportation, and many other spaces. Okay. So in conclusion, what I talked about so far is we have lots of data, and our systems, they are making a much more data-driven decision-making instead of just doing a reactive. Instead of just being a reactive system, they are much more data-driven and much more intelligent systems. And that in one way or the other helps it also do some sort of a maintenance task in the back end, right? So if you also think of the cars, so let me take an example of if the algorithm has to understand what temperature the vehicle is sitting in for months, it may tell that how is the tire pressure changing based on the temperature of the outside environment, right? So based on that, it may understand that the data is showing something serious and the tire pressure is not looking good and some action needs to be taken. So those fall into the maintenance kind of the tasks. So those also happens. And all of this is concluding into what we call enabling or enhancing the autonomy of the systems where we are including the AI with. Now, we are also, at the core of all of this, the driving force is what? We just talked about data, right? And in the current era, we are seeing an unprecedented data explosion, right? So also a projected number which says that about 2025, these connected devices that are present, including the IoTs, CPS is just a part of the IoT. So they are going to be generating about 75 zettabytes of data globally, which if you understand terabytes, then they can be a billion of terabytes. That's how we look at it. And in particular, taking an example of self-driving car, they are already generating a terabytes of data per hour. Now you can imagine the kinds of data that we have and how we should carefully use it. And all of this data, as we talked about, is used to fuel the algorithms that are using them to make much more accurate predictions, optimize the complex processes, and develop much more reliable and innovative applications across the fields. Right? So here we are talking about the efficiency gains. Let's take an example of the manufacturing assembly lines, right, where robots are there trying to put the various parts together to form some parts of the, let's say, an automobile, right? So it has been seen that when with AI or with the inclusion of these robots that are enabled with AI, the efficiency gain has increased by 30 to 50%, as opposed to when these services were done by manually by the humans. In addition, it has been observed that the various places where human error was obvious, those places there has been a reduction in the human error. Now, human error also happens because sometimes humans get tired, right? Like if you're working for 24 hours in the same plant, at one point in time it is possible that the precision will be miscalculated by the humans. These robots are not going to make because they are trained to do only one task 24/7 and they will do it as it is. And all of this is supposed to be transcending the various critical fields as well. So you will see this kind of scalability and performance optimizations in healthcare, manufacturing, as I talked about, and transportation, and so on. So I talked all good things so far, right? So AI is enabling a lot of things, yes. But we are also at this stage where we have not reached full autonomy or full reliability or fully 100% success at achieving a certain task. No. At the cusp of all of these innovations that are happening, there are also challenges associated with these advancements. And there is a need that all of these complex and sophisticated methods, they are transparent. They need to be at least transparent. Because in the face of adversity or in the face of any miscalculations that happen, who do we blame? What is the ethical considerations that may happen? Who do we go back and hold accountable for something that happens, right? So for instance, we very often come across these self-driving cars where we hear about them colliding with each other, or they would have violated the traffic lights, or they would have run into some passerby and so forth. Now, if they hit somebody and if there is an accident scenario, who are we going to go and claim to? And there have been such scenarios where those accidents have happened and cases have been filed as to who should be held accountable, and in the end, nobody was held accountable. because it's easy to evade these scenarios because no human was responsible for conducting these kind of accidents, right? Similarly, yeah. Similarly, we also, I don't know how many of you heard about it, but last year we heard about this ransomware attack that happened on the one of the most critical health infrastructure of the country. And you cannot even imagine about 1.3 terabytes of data set was compromised. And imagine the level of risk that went out of the authorities. So the patient's data, the surgery processes, or any kind of confidential health data, all of this was compromised. In addition to this, the hospital was halted for about 24 hours or so. You can imagine the kind of criticality that, or the overload that would have put up on the system, because these are the facilities where the patients from across the countries are reliant on. So the thing that I'm trying to say here is some of these issues that may not appear relatable to you directly because they do not affect you. They are not tangible in nature. But some of these, they are very tangible in nature. There is something that happened in the background which is now affecting the humans, the real lives that are there in person. So, and this is going to become even more and more evident as we go ahead and further in the future. The reason being, every second we are having a connected device that is connecting to the internet, right? So, and this is going to go even lower and lower. Like every fraction of millisecond, you will have such devices connecting. And imagine the number and amount of vulnerabilities that are opening up, right? The more number of devices you add, the number of vulnerabilities grow. So that's what is happening here. So the thing that I'm trying to say here is, all of these incidents are a reminder that with great power comes greater responsibility, and we need to be making a culture where there needs to be continuous improvement of these systems, robust testing, and ethical consideration of how these systems are behaving with respect to the systems that we are developing. And that is very, very necessary. Now, all of this now reminds me some of the great words from the remarkable Grace Hopper, who is a true visionary in computer scientist, as all of us know. And she once in her talk said that a human must turn information into intelligence, and the information is at the core, and that we need to develop systems around the information and not just do the vice versa. And so we know we have a vast amount of data, and we need to be responsible and develop systems that are much more reliable, trustworthy, that benefits the humanity. So with that, thank you for your time and attention. Happy to chat about these topics offline if you're interested. You can connect with me on social media. Thank you so much.
I'd like to thank Shailija Thakur. I'd like to request Vandana Soni, Session Chair, to please come forward and present Shailija with a small token of appreciation. Once again, we'd like to thank Shailija for that lightning talk on the topic AI in cyber-physical systems, technical innovations, and social implications.